Hi everyone, welcome to our video on instantaneous rate of change. To begin it, let's start with our question from the average rate of change, where we had this table, and our question now is, going back to my trip to Dallas, what was my velocity at exactly 2 hours into the trip? Okay, so this was the time every half hour, and then this was the distance traveled to get to Dallas. Okay, and then we have a note. So we found some things earlier. We found the average velocity over the entire trip was 63.3 miles per hour. And the trip's velocity between 1.5 and 2 hours was 80 miles per hour. So we did have two there. Notice they are different. Well, here's what's tricky about this. So what was my velocity at exactly 2 hours? Well, I can't just divide these two. So that would still be an average velocity. So our average velocity, if you're saying, hey, distance divided by time, well, this is the distance doing from 130 to 0. So it is still an average over the time, 2 minus 0. So that would have been 65 miles per hour. So this average velocity is the average velocity of the trip from 0 to 2 hours. So the 65. So it doesn't match. So you can't just take these two and divide them. Okay, so what we have is a lack of data. We can't really answer this question. We would really need to be in the car to know it. And so we need to figure out a different way to answer these. And that's using a new function. So we don't want to just do the change in the distance over the change in time. We wanted to be able to find, so the instantaneous velocity, so the velocity at exactly 2 hours. Let's write it like this. The velocity at exactly 2 hours has an issue in that denominator, because at exactly 2 hours we would say that the time doesn't really pass. Time did not pass. So whatever minus whatever is really going to be close to 0. Well, we have a way around it, and that's in this instantaneous rate of change formula. So the instantaneous rate of change, which we'll call IROC, measures a change in a function at the moment x equals a. Okay, so what we've got, let's box this up. And there's one other formula that goes with it as well. However, I think this is the one that is easiest to use. So this is the one I will be sticking with. So it's the limit as h heads towards 0. So this is saying as h gets very close to 0. So that way we can kind of go around dividing by 0. Remember, if you do divide by 0, that is an undefined. But what this is saying is that the limit is just getting very close to it. So it's just saying it's very close to 0, but it's not actually 0. So we could still divide. Okay, so this is our average rate of change. This is also going to be called something real soon. We've got our tangent line. Let's read this first. So a tangent line is a line that goes through the point of a function that has the slope that is equal to the instantaneous rate of change. So often we say that this has the slope of the tangent line, and the way that we write that is m with a little tan underneath. Okay, so just to draw, so we'll just make a picture up. Okay, so say I've got something like this, and say I'm concerned about this point right here. Well, what this function is going to do for us is it's going to find that tangent line. So this in the red is the tangent line. So it's going to go through just a single point. That is the tangent line. And what this does is estimates the instantaneous rate of change of this function. Okay, so and this slope has the same slope. Let me go ahead and mark it with this too. Our m is the same as the instantaneous rate of change. Okay, so there it is. And what it has, let me draw one other picture too with it. So what's happening and how we get this. So it is a special slope. So I'm still trying to draw the same picture. What they do, so it's similar to the secant that we saw from a different video. But what we're concerned with is this point. And the way that they treat this is they just say, hey, how about we just make the run h? And then let's go ahead and say, hey, this point right here, this was x comma f of x. So our x coordinate goes into our function to get a y coordinate. And then if we're saying if this length is h, Then from x, I can add h to it, because that would be a horizontal length. So x plus h would be that point. And then again, I could just plug this into my function to get my y coordinate. So f of x plus h. And so what we have is that if we're going to do our slope equation, I have my y2 minus my y1. So there's that. There's the y2 minus the y1 in our formula, divided by the run, which is the h. But what they want to happen very soon is to make this h head toward 0. So that means this distance, this horizontal distance, is going to close in on this point. So we want this h to be as small as possible, which means we really have this point headed toward this point, like that, and then they will overlap. And then that way, the secant line that I didn't draw from that point to that point is getting shifted into the tangent line, and we have just one single thing like that. Okay, so that's the geometric visual of it. All right, so let's see how to deal with these problems. Well, I guess before we deal with them, let's just work on one or two problems where we just get used to evaluating these strange kind of scenarios. So let's review before we jump into the instantaneous rate of change problem. Let's evaluate. Okay, so here we have f of x. What I want to do is evaluate f of 2 plus h. Okay, so 2 plus h is just going into your x's. So it's 4, and then 2 plus h, getting squared, plus 5. So that's all we had to do. And then afterwards, we usually have to FOIL that out. So f of 2 plus h equals 4. Now 2 plus h, now let's just I'm going to do some scratch work over to the side. So 2 plus h getting squared, this does need to get FOILed. Remember, if it's ever got a plus or a minus inside parentheses being squared, we should rewrite it out where it's multiplying it by itself. And then that way we can FOIL 2 times 2 is 4, 2 times h is 2h, h times 2 is also 2h, h times h is h squared. And then the 2h and the 2h are like terms, so we can combine that to make it into 4h. Okay, so that FOILed into this, so I just did some scratch work since I would have ran out of room. So we have 4 plus 4h plus h squared, like that, plus 5. And then afterwards, I could distribute the 4. So let's take that 4 and distribute. So it goes to these three terms. So I'll have f of 2 plus h is 4 times 4 is 16. 4 times 4 4 times 4h is 16h. And then 4 times h squared is plus 4h squared. And then plus 5 is still out there. And then finally, we can just combine our constants here. It looks like we have 16 and positive 5 would combine. So I'm going to write this as f of 2 plus h is 5 plus 16 is 21 plus 16h plus 4h squared. Okay, so it's just evaluating functions. Remember, to evaluate, you just plug in whatever they want you to plug into all the x's or whatever variable they use. So on this one, we see t. Okay, so let's do one more practice one before we jump into the instantaneous rate of change problem. All right, so let's evaluate the f of negative 1 plus h. Oh, that should be s. So I made a typo. That's s because our function is s. Sorry about that. Okay, so should be s. Okay, so when we do this, let's set it up. We have s of negative 1 plus h. Again, all I'm doing is just taking that t and changing it into the negative 1 plus h. Okay, so I have negative, and remember to use parentheses. So negative t gets substituted out with that parenthesis expression, plus 2 times, again, parentheses, like that. Okay, and then now, again, it's very similar where I would need to FOIL this out. So let's set this up. Let me use some colors this time. So in the blue, I would need to FOIL. I think that should be enough space. And then let's write the plus 2 times negative 1 plus h. We'll come back to that soon. Okay, so anyway, so this I need to FOIL again. So the negative 1 plus h squared is negative 1 plus h times itself. And then when we FOIL, we'll have negative 1 times 1 is positive 1. Negative 1 times h is negative h. H times negative 1 is also negative h. H times h is h squared. And so negative h and negative h become 1 minus 2h plus h squared. Okay, so that's what that foiled into. So we have 1 minus 2h plus h squared. So I kind of like doing the scratch work. You could keep it all in one line too if you want, but I think my room was going to get a little tight there if I did. All right, so now our next step would be to distribute. Let's show that in red. So this negative is going to change all these to their opposite signs, and then the positive 2 would multiply those by 2. So we have negative 1 plus 2h minus h squared, and then minus 2 plus 2h. Okay, so the 2 multiplied, and I think double check all the signs. Yep, it's looking good. And then now it's the very last step is to combine like terms. I have a negative 1 and a negative 2. So these I'm going to combine. I'm going to underline. So that's negative 3. And then I have a positive 2h and a positive 2h. That's positive 4h. And then the negative h squared is still just there, so minus h squared like that. And then that's it. The order doesn't matter how you arrange these things. Some people like to see the h kind of like descending order. Negative h squared plus 4h minus 3 is also good. Okay, so it doesn't matter how you do it. I'm going to go ahead and just box both of them. So either answer is fine. Same deal with the first one. I could have rearranged if I wanted to. Okay, anyway, so that's setting these up. All right, so let's see how we do an actual instantaneous rate of change problem. So I've got 2 here. We'll break them both down. All right, so to find the instantaneous rate of change, well, first thing, just like the average rate of change, is to write down the formula. So the instantaneous rate of change is your limit as h goes to 0 of f of x plus h minus f of x over h. And then the way that I'm going to do this, all right, so I'm going to take it apart just like I kind of did in the other problem. So step 1 is to evaluate the f of x plus h, but they're saying use x equal 2. Okay, so that means I want to change these x's. Let's rewrite that first. So I'm going to use my color still, but let's rewrite it. So they want us to find f of 2 plus h minus f of 2 over h. And then, well, this is really an order of operations problem. We need to evaluate this function. We'll need to evaluate this function. Then we'll need to subtract the 2, and then we will need to divide. Okay, so let's break that down. So my first step, I'm just going to label it like here, number 1. My first step that I'm doing in blue is to simplify the f of 2 plus h. And so that is using our f function to change those x's into 2 plus h's. And so I already did the first one right there, already changed. And so then I have 3 times 2 plus h squared minus 2 plus h minus 1. And again, remember to use the parentheses when you sub in these expressions. So because this minus will need to distribute. Okay, anyway, so we would need to FOIL this out, the 2 plus h squared. If you need scratch work, that's fine. I'm just going to do a quick scratch work kind of above, so I don't have too much space here. So I'm going to do 2 plus h times itself real quick to get 2 times 2 is 4. 2 times h is 2h. H times 2 is also 2h. H times h is h squared. And then these two would combine. Let's go ahead now and just plug it in, though. So we have 4 plus 4h plus h squared. Okay, so that portion has been FOILed. And then I still have the minus 2 plus h minus 1. Okay, and then just like the last problem, well, we would want to distribute. So this 3 would distribute through, and the negative would distribute. So we'll have this becomes 12 plus 12h plus 3h squared minus 2 minus h minus 1. Okay, and then now one more time, I'm looking to simplify. So it looks like I have a 12 minus 2 is 10 minus 1 is 9. And then we have, okay, so maybe I'll use some highlighters. And I've got 12h and minus h would be 11h. So we have plus 11h. And then we have the plus 3h squared, which didn't have any like terms with it. So there it is. Okay, so that's that portion. So now I'm going back to my equation. I still have the limit as h goes to 0 of, and then everything, so this blue parentheses is the 9 plus 11h plus 3h squared, just like that. And then now I need to do the minus the f of 2. Well, we need f of 2, so I'm going to say this is like our second portion. Just to the side again, here's step 2. Okay, so these problems are kind of a mixture of a lot of scratch and a lot of plugging back into the formula, so I like to break it down into pieces. Okay, so now we have to find f of 2. Well, again, that's just, here's our function, f of 2. Plug 2 in for those x's, so I have 3 times 2 squared minus 2 minus 1. Now this one's a little easier to simplify. We have 3 times 4 minus 2 minus 1. It looks like we would have 12 minus 2 minus 1. So 12 minus 2 is 10, minus 1 is 9. Okay, so this in the red is just minus 9. Okay, and it could help to keep the parentheses in case there's more terms than 1. Okay, and then it's still divided by h. Okay, so now that we've evaluated these though, now all I have to do is look at my numerator here, and now I want to simplify. And it looks like I have 9 minus 9 would just cancel each other out. 9 minus 9 is gone. Okay, so that gives us the limit as h goes to 0. So again, 9 minus 9 is 0. And we're left with 11h plus 3h squared over h. Okay, and then now at this point, I would factor. So notice that, and when we simplify, we should only have h terms left over in our numerator. So only h terms now are left over. And so that means we should be able to factor. Factor out h. And so if we factor that out, we'll have our limit as h goes to 0. Okay, so taking an h out of the top, I would be left with 11 plus 3h. Just like that. And then now I still also have divided by h down below, but now I have my rule where the same thing divided by itself would cancel. And we need to factor that first. So don't take this h and cancel that h in the previous step. Remember that it has to have the same number of terms to cancel. So currently up top, I would have 2 terms divided by 1 term, so they don't mix well. Whereas this is 1 term times 2 terms, so this is 1 term by itself, which means it could divide that 1 term by itself. And then so now I have just enough room to finish it off. So now the h's are gone, and we're left with just 11 plus 3h, just like that. And then now I can plug h goes into for 0. And then, well, I'd have 11 plus 3 times 0. So I no longer have the limit. I have just the numbers. And then, well, 3 times 0 is 0. So this is 11. Okay, so that is our instantaneous rate of change for that function at x equals 2. Okay, so it's a just right now abstract. All right, so we just want to make sure we can use the formula. Okay, so that's one of them. Let's go ahead and do this one in the same video, so it'll be a little longer maybe. But if you need to take a break, take a pause. We have a different scenario though, and I want to just continue it. Okay, and one thing about these problems, before we do move on, is once you set up your instantaneous rate of change, I'll just write it in this one since it's also the instantaneous rate of change problem. So as soon as you see that, get your formula. So the instantaneous rate of change is the limit as h goes to 0 of f of x plus h minus f of x over h. I'm going to say it right now and just kind of block it off. I'll do it in purple. So kind of our goal, so these were the steps that we took to break it down. And we could even write those steps in words for this problem. But kind of our main goal is to get that h to divide out eventually. Okay, so the main goal is to cancel the denominator h. So that's usually all we're trying to do in these problems. It takes a while to get there. Look how many steps this one took. But that is kind of if you want to think of it as just one big thing that we want to do, is that. Okay, but anyway, now let's do this problem. Okay, so this time around, they want us to find the instantaneous rate of change. Well, they used g instead of f, so that means I'll have to change it. But they also say they want, and they use w. G of w equals 5 over w at w equals -1. Okay, so what I'm going to do like two things in one. So we know that x is pretty much the w in this case. So that's what I'm going to change that into. So we have the limit as h goes to 0. And instead of f, technically I should do g. And then instead of x, well, it would have been w, but I would change it to this number anyway. So -1 plus h minus, and then again, instead of f, it really should have been g. And then the x was really w, but w's changing into -1 anyway, like that. Okay, and then now we go through our three-step process, so or multiple step process. So I didn't really number everything after 2, but what we need to do is 1. We need to evaluate the functions, and I did that as 1 and 2, but let's go ahead and say we need to evaluate the functions. Okay, so let's break that down. So let's keep this one in blue like we did last time. So the first one's in blue. And then it is just evaluate. Okay, so I've got g of -1 plus h. I'm looking at my function again, which is right here. Let me go ahead and just highlight it. Or no, let me box it to kind of see it a little better. Okay, so this is our function. So I'm changing the w into -1 plus h. So I'd have 5 divided by -1 plus h. And then that's it for this problem. Okay, so sometimes you don't actually have to do too much. The fraction is simplified. So notice on this one we had more steps to do. But on this one, that's it for now. Okay, and then my second step, or still evaluate the functions. Let's go ahead and I'm just going to put it to its side since I think I have plenty of room. I want to do the g of -1, which is 5 over, so I'm putting the -1 into those w's, so which is 5 over -1, which is really just -5. Okay, so there's that. All right, so what we have, now we'll sub those into our equation. So evaluate the functions and then plug them into your formula. And we've got, so in the blue, we have the 5 over the -1 plus h. And then we have minus the red was -5, so we could simplify that right there, all divided by h. Okay, so that's what that looks like, but then let's go ahead and simplify in this step. So I've got the limit as h goes to 0 of, in the blue, let's keep our colors, so 5 divided by -1 plus h, and then negative and a minus would become plus, so let's just write that as plus, and we'll keep our red as well, 5. So plus 5 like that, still divided by h. Okay, well, the strategy I usually used in these problems when we had our limit scenarios was to take, so I'm putting the parentheses in, so I have my big numerator and my big denominator. Usually our goal is to, so our next step, so evaluate the functions, we did, and then plug them in. Our next step now is to simplify, so starting here is to simplify. So this is our step 2, so simplify this expression. And well, it depends on the scenario that we have. Like in the previous one, simplifying was just collecting like terms and it wasn't a big deal. Okay, so and it kind of goes back to our rules of limits. So simplify based on the 3 different kind of things that happened in limits, where we're either just combining like terms / comma factoring. Here we've got a complex fraction, So I'm going to multiply by the small denominator to eliminate. Multiply by small denominator to eliminate. That's definitely not the word eliminate, but eliminate fractions. Okay, my pen's a little tough, but multiply by small denominator to eliminate fractions. And the other case that we might have is if you have a square root, then we would multiply by the conjugate. Okay, so those are three of the main ways that we can deal with these problems. Okay, so with this one, since we have that denominator down there, that one, I'm going to multiply everything by that -1 plus h on both the top and bottom to simplify. So that way I'm going to get rid of the complex fraction. So I'd have the limit as h goes to 0 of, okay, so when this green expression multiplies this blue expression, well, the -1 plus h in the numerator would cancel with the denominator, and I'm left with just that 5. And then we have plus 5 times, and then this just multiplies the 5. There's nothing it cancels with, so it just multiplies the 5. So it'd be written just like that for now. And then down below, we typically just leave that alone. So remember from our limit problems that were like this in that own specific section, we usually just left it alone. Because again, I'm thinking this main goal, this h, is what I need to cancel. And so it's best to just leave it separate. Okay, but now let's continue simplifying. So we're still in step 2, simplify this. So we've got the limit as h goes to 0 of 5, and then positive 5 distributes to give us -5 minus, nope, not minus, plus. So positive 5 times positive h is positive 5h over h times -1 plus h. Okay, so what we mentioned it before in this problem. So notice that when we simplify, we should only have h terms left over in our numerator, and that is true as well as in here. So note we should only have h terms once it simplifies in the numerator. Only h terms in numerator when fully simplified. Okay, so if there's something else besides some other h term, so if there's some constants in there, so if this was 5, say for instance we accidentally didn't see the negative and we did 5 plus 5 is 10, well, I'd have a 10 with an h term, and then so I know something's wrong. Okay, so this should again always simplify, because again this h should cancel eventually, and in this problem it's looking good. So 5 minus 5 is 0. So we're left with just 5h over h times -1 plus h. Okay, so all the simplifying is now done. Now our third step is to cancel the h's. So step 3, I'm going to put a little higher. So step 3 is beginning right here, where I should cancel the h. Cancel h somehow. We might need to factor. So I'm gonna put somehow. So sometimes we might need to factor. This one, it's clear. It's just straight away we can cancel. So like again on the previous one, we had to factor first before we canceled. Okay, so cancel h somehow. So again, we might need to factor, and then afterwards we'll evaluate the limit. Then plug in h equals 0 to evaluate limit. Okay, so the h's, I'll highlight those in the yellow. So these h's cancel, so that denominator h needed to cancel. And then we're left with the limit as h goes to 0 of just 5 up top over -1 plus h down below. Okay, and then now I can simplify this, or we can answer it. If I plug 0 into our h, it looks like we're going to get 5 over -1, which gives us -5. Okay, and that's a coincidence with the red evaluation from number 1. That's not always going to happen. Just on this one, it looks like it did. Okay, so anyway, so that's abstract again. So we're just making sure we can understand the formula for this scenario. You can also check these types of problems. I mean, you do have to be able to set it up well still, but I'm going to star this so that once you evaluate the functions, so right here is something that you could plug into. Okay, so I'm going to show that in the last couple minutes of this. Okay, so I'm back to my friend Desmos. Okay, so I'm going to use the graphing calculator. Now, it's H in this scenario. Or no. Let me use the actual, let me go back. Let's go to the scientific calculator instead. I think this would be easier. Okay, so all I'm going to do is if H is going very close to 0, I'm just going to plug in like 0.00001 or whatever and make this expression into something that is just algebraic or arithmetic in this calculator. Okay, so for instance, we could just plug in 0.00001 whatever and see what it looks like. So we have parentheses. I'm doing 2 parentheses because I'll have that big denominator. So I'll have 5 divided by -1 plus, and again, I'm going to do point. Let's do 5 zeros. 1, 2, 3, 4, 5, and then 1. And then we'll do our parenthesis. Oops, I don't need that parenthesis. Let me make sure I move over, and then the parenthesis. And then, so that's the blue. Minus -5. I think we could just say plus 5. And then parentheses. So that's the numerator. Divided by, and then this H, we're going to do 0.0. We need to make sure it has the same 0. So 1, 2, 3, 4, 5 zeros, and then 1. And then look at this, -5.00000 whatever. It's looking like it's close to our answers. If we want to, we could plug more zeros in. So if I do 2 more zeros here, 1, 2, let's get 1, 2 there. And it looks like it's just getting closer to -5. It's just more zeros. 1, 2, 1, 2. Okay, so it's really looking like it's just -5. Okay, so you can still check with the calculator. We know our answer goes to just -5 though as a final answer. Okay, anyway, so that's it for now. So that's using these formulas. Okay, so if you see instantaneous rate of change, make sure you know the formula. Sometimes they don't give it to you, so we want to make sure we do know it. And then from there, it's our kind of long 3-step process. So these problems are long, so take your time with it. Know that you're in it for a little bit, and again, you can use the calculator to help you out, but either way, it's long. Okay, so that's it. So thank you for watching. If you have any questions, please let me know. Otherwise, I'll see you next time.